Hello everyone, welcome to Computer Science E7. This is lecture 6, the histograms. So we've gotten all the Monday holidays out of the way, so we're in it for the long haul now. So now though we get to really get into what I think is actually the best part of this course, because before it was sort of the fundamentals of photography. You can think of it. The first half of this class is really meant to get everyone on the same page regarding really important photography terminology and exposure. I mean, this is some of the fundamental stuff. And so I know that I've been going a little bit fast through some of this stuff, and I apologize if it's a lot of bit fast. But now that we're getting to some of the good stuff here, hopefully we'll be able to slow it down a little bit and talk about some of this stuff as it pertains to digital photography, which is presumably why all of you are here. So today we're going to be talking about the histogram, and as you probably or you might know, most digital cameras, if not all modern digital cameras, have the ability of showing you a histogram. And you might wonder what on earth we can talk about for 2 hours about a histogram. But we're going to be laying even more fundamentals down that we're going to be using throughout the rest of this semester. And so there's going to be a lot of good stuff when we're talking about it today. So a histogram, what is it? Anyone know what a histogram is? Any math majors from back in the day? Histograms.
It's a
Sorry?
graph that shows ranges of information.
Right, good. So it's a graph that shows ranges of information. So a histogram is not photography specific. It can be very, very general. So for example, this is a histogram of black cherry tree height. So basically what it shows you is it's showing you a count of information. So how much of something that exists. So in this case, there's a height for black cherry trees. They range from about 60 feet to 90 feet tall. And then it shows us on the y-axis the count of how many trees actually exist at each of those particular heights. So as you can see, we have about 3 at height 60. So in the range of 60 to 65, we have 3 trees. 65 to 70, we have 3 trees. 70 to 75, we jump up to 8 trees, so on and so forth. So unfortunately, I have to show us this somewhat, this is not a very relevant histogram. Back a couple of years ago when we first started doing this class, this lecture, the histogram, came right after the exam lecture, and we had a really nice histogram of how everybody did. And it tended to be sort of like this, right in the middle. And no, I'm kidding. They did very, very well. But basically, now we have to show this sort of irrelevant one, really. But this really, it just shows a frequency of how much of something there exists. So the ones that we see in digital cameras are maybe, they look a little bit more organic in a way. There's much more data that's visible within them. There's a much finer grain amount of detail. You can see that if you look closely, there's individual bars still, but it looks a lot smoother when we look at it from far away, as in this slide, or as on our cameras, or even in Photoshop, for example. But basically, this tells us some very important things. So along the x-axis, we have a range of basically darkness, so dark all the way to white. So we have at the very far left at the end the amount of black that exists in a photo, and all the way at the far right the amount of white that exists within it. And then as we get within a range somewhere in here, there is a count. So the higher the bar in that particular range, that means the more of that one specific tone there is. Now, you might think right here, okay, this seems like a really good place to stop, because that's a histogram. I've explained it, and now you can look at a histogram and kind of say, okay, well, it should sort of be right in the middle, because you don't want a lot, in the very dark region. You don't want a lot in the very light region, or you could be under or overexposed, respectively. But there is a lot more detail that can be said about this. So first of all, the amount of information that exists between here and here, it's not just black and white, obviously. There's a bit of gray in here. And this gray that exists, this gradual change, is basically the tones that exist within the image. And so we have a couple of really important concepts that are come into play here. So we have one concept called dynamic range, and then we have another concept called tonal range. And dynamic range is basically I'm just going to introduce it quickly now, and we'll talk about it more at the end of the lecture. It's basically just the difference in dark to light that we can get. So basically how many stops we can capture in an image. So if we have very, very wide tonal range, then maybe we would be able to get more details in the shadows or in the highlight of a very difficult scene. For example, if there's very, very harsh sunlight, as you might know, you get very bright light on the face of a person, and you get a very harsh shadow. A better dynamic range means that you'll be able to preserve details in the very brightest and the very darkest regions. If you have less dynamic range, then it's going to become overexposed much more quickly in these difficult situations. Now, tonal range, which is much more important to us when we're talking about histograms, is basically the amount of gradation that we have in the middle here. So how many tones we have from this deepest black to this brightest white. So if we have a wide tonal range, then we could have these very smooth gradients, as if we have just a picture of something that goes slowly from black to white, for example, it would look very smooth. There's not this sort of a step that you would see as the brightness level goes from dark to a little bit brighter to a little bit brighter. It will look a lot smoother if we have a larger tonal range. And that's something that's very important to keep in mind as we move forward. But okay, let's go back to histograms here. So what I'm telling you about histograms is that it's just a frequency count of basically the tones within an image. So if you have, in this case, in this histogram's case, you can see that we have a very high amount of tones in sort of this mid-bright region. So not right here, not right in the middle, but it's sort of middle bright, which actually would be pretty good. But if we take a look at some real-world examples of histograms, for example, a total underexposure, where we just completely messed up, or we took a photo with the lens cap on, or something like that, and it was a completely black photo, then what you would expect to see is this. You have nothing that's brighter than completely dark, but you see just this very tall, sort of black column that exists at the very left side of the luminosity. Now, you can imagine what happens if we have a total overexposure. Let's say that we were using the manual mode and we were taking a night scene, for example. So we have a really long exposure, maybe low ISO, so on and so forth. Then we put the camera away, then we come back the next day and take a photo with the same settings, forgetting that we had used those settings, and it's completely white. What would the histogram look like in this case? Yep, exactly. So we have a bar that's completely on the right. Now, obviously, this is not going to be the general case for photographs. You're not going to have one color, one tone that's going to be completely white or completely black. And in fact, I should mention that this is just a window taken basically from Photoshop. So if you have seen a histogram on your own camera, rest assured that what we're talking about is important for not just that, but also for some of the tools that exist for your computer today. But going back to these photographs, this is generally not the type of photograph that we take for artistic reasons. So what we might have is something much more like this. So this was the pinhole photo from last year, but it shows, the whole point of this is that we have the photo and then the histogram right next to it. It shows us the histogram that exists there. Now, one thing that's really important to mention about the histograms is that when you take a photo, generally you're chimping over your camera to take a look at what the photo looks like, and you're looking just at the photo. Now, this can be very, very deceptive for a variety of reasons. One of them is that the LCD on the back of your camera is not going to do a very good job of showing you just how light or just how dark that is, depending on the lighting conditions that you are in. So for example, if you are outside, it's really bright, really sunny, most likely your LCD is going to be washed out and it's going to be difficult to tell just how bright or just how dark that is. And on the other side, if it's completely dark, then what can happen is that it will look brighter than it actually will once you put it onto a computer, for example. And so this is a very bad combination. When you're in the dark and you're looking at a photo and it looks brighter, then you might say, okay, well, I'm done, but you're really not. It actually was much, much too dark. It was very underexposed compared to what you want. And so this is where the histogram can come into play, where you can try to fit the tones within the photo into sort of the center region of the histogram. Now, what I'm trying to show you here are some well-exposed examples of what a histogram would look like, but you will see that there's not one sort of formula that a histogram follows in order to be correct. So this one's very easy. There's all of the tones fit within the dynamic range of the camera. There's nothing that's brighter than the brightest white that the camera is capable of taking. There's nothing darker than the deepest black. And the reason that I know that is that all of the tones, as shown by the histogram, fit within the histogram. There's nothing at the far ends, as we would see if it was if there were some pixels that were completely overexposed, we would see a little bump all the way on the right side, and vice versa for underexposure. Okay, so keeping that in mind, as we look through some more examples, here's one where the dynamic range of the scene is perhaps a little bit wider. There's a wider change in the amount of brightness or the amount of light in a scene, and so we have then a wider histogram that exists. And one of the things that you'll notice, though, about this histogram that might be tricky is this hump down at the very far left end. It looks predominant. You might look at this, and if you were looking only at the histogram rather than at the image itself, you might say, well, this actually could be a little underexposed because the majority of the pixels that I want are at the far left end of this histogram. But that shouldn't fool you, and I'll explain why in just a little bit. Now, is there anything that's pure white in this scene? Yeah, sure. So yeah, right here we have the t-shirt. There's a little bit of overexposure there, so we lose some of the details. And even though, as we saw a couple of slides ago, that total overexposure would show us a big spike on the right side, even though we do have some overexposure in this image, it's really tough to see. There's a little tiny blip that's over here. And in fact, the blip that you're seeing probably isn't even it. There's a smaller one that's right next to it that represents that overexposure. And so sometimes cameras allow us an additional opportunity to see overexposed regions. Sometimes it will flash overexposed regions in a different color, like red, or usually it's bad if they do it in a color, because that's if you overexpose just red, for example, then you don't see it flashing, so it's kind of silly. But if they flash it in black, for example, then you would be able to see that that particular region is overexposed. And in a scene like this where there's a lot of light, you're probably not going to be able to do anything to get a better exposure, frankly. If you wanted to decrease the exposure value so that this was then less overexposed, right? You turn down the exposure value so you can get it to be better in terms of the exposure, then everything else could look underexposed. Okay, so let's take a look at a few more examples. Here's another one that we've seen before. This has quite a large dynamic range, this scene, because as you can tell, we have quite a few regions that are very, very dark, particularly the upper left-hand corner, and then we have some regions that are completely white, so as in right here above where a light was, just underneath the waterfall. And that's reflected in the histogram. We have a very large spike here along the left and just a little bit of white along the right side here. Now, so remember that no one histogram formula makes it right. So each of these could be considered well exposed, and the histograms, as you can see, vary by quite a large margin. So you can't just look at just the photo on your LCD screen. You can't just look at the histogram. You really need to look at both and try to make a determination of the exposure, of the final exposure of your scene. Now, one of the things that's important to realize is that the histograms that the cameras show you and that your computers show you are a fixed height. They don't get any higher, they don't get any shorter than the height that you currently see. So right here, I have this very, very big spike, and it has to fit that spike along with these other sort of valleys or these other peaks and valleys that exist within the histogram onto that same height. So what the camera does is it will tend to shrink the histogram. It will just compress it down a little bit. It won't change the width at all, but it'll make it a little bit shorter, or it'll make it a little bit higher to try to make it a little bit more apparent what some of these histograms are. And that was sort of the problem that we saw here. We have quite a few pixels that are a little bit darker, which is sort of the background region that exists here. And even the shorts and the shadows, there's a variety of regions in here that are darker. But it doesn't contribute to an overall underexposure of the image. And so once you realize that once the camera or the computer calculates the histogram and it changes the height to fit in that fixed height histogram window, then hopefully it will make a little bit more sense that, sure, this might have been stretched up a little bit. So, well, keep in mind that everything gets stretched the same amount. It doesn't change the height of each, because then it makes the whole histogram useless, really. So all of this stuff could be stretched up. So it looks like there's more area under this graph versus this, for example. And the reason is that this one black bar that represents this complete underexposure in this photograph is taking up most of the height, and everything else has to be shrunk in comparison. And so this can be confusing, particularly when you are intentionally forcing an underexposure or an overexposure, as in this case. So in this case, there's the majority of the pixels are black or very, very close to it. And even though there is a considerable portion of the image that is properly exposed, the histogram is going to sort of fake you out. You'll only see a little bit of a blip. As you can see, there's a little bit of a hump right in sort of the middle of the tonal range that represents this properly exposed portion of the photo. The majority of this photo is black, so it's going to be represented by this far left area of the histogram here. And similarly, for complete overexposure, we have this, where we have this very, very large overexposed region, and we have just sort of a very small hump in the middle of the histogram. So if you are intentionally trying to force an overexposure, this could be something to watch out for. But if you are not, if you're just trying to regularly expose an image, then you should look for a very, very sharp spike on either end and try to adjust accordingly. Now this is sort of the pitfalls of the histograms, but keep in mind that this is really, really useful to us. So for example, we have this snowscape shot that I showed when I was demonstrating the exposure values, or the exposure compensation rather, from a couple lectures ago. Now, when I first took this photograph, it was getting sort of dark outside, and I looked at the photo and it looked fine. And this was that problem that I was telling you about, where it's somewhat dark outside and the photo looks brighter than it does. Well, this looked white enough to me that I said, okay, that's it. And I actually left this scene before I said, maybe I should check the histogram. So while I was about a block away, I realized that the histogram was way down here, indicating that the majority of the pixels are actually quite underexposed. And so I had to go back, walk all the way back to this stupid place, take a photo, and it's not even that interesting of a photo anyway. It was a big waste of time. But anyway, it wasn't a waste of time because I get to show it to you and use it to explain. But anyway, so now after you force this overexposure by increasing the exposure compensation by about a stop and a third, as was the case here, then you get a more properly appearing histogram. So especially with snow, you want a histogram that leans primarily to the right end of the spectrum, because you want a lot of that white snow visible in it. You don't want to go too far. If you go too far, you'll overexpose some of these pixels, but there's a little bit of a gap here, which shows you that you will have some values that exist within these white regions in the snow, and you'll be able to see all of this information a little bit more clearly. All right, now I have to embarrass myself once again and show you this awful photo, where you remember that I pretty much completely overexposed the sky and then completely underexposed the bridge. And if I had bothered to look at the histogram at the time, well, I mean, it was obvious also from the photo when I just took it. But when you take a look at the histogram, it does become very obvious the problem that exists, and that is that the majority of the values are just so far off to either end of the histogram that the dynamic range of this scene is just far too wide. It's just too much, there's too much variation in the brightness of the scene for my camera to be able to get it. All right, this is easy, right? Piece of cake. Now you're saying, okay, before you faked me out a little bit when you said that, that's sort of the end of all the stuff that we had to talk about with histograms. Now I could do it again and say, okay, well, we've got into more detail about histograms, and that's it. We could pack up and go home. But the problem is that the devil is in the details. And so we have to go back to this lovely slide from the first lecture, and this is where the digital aspect of digital photography is really going to come back into play.